Hi everyone, in this video we're going to talk about even and odd multiplicity. So, let's get right to it. What is multiplicity? So if you look here, we have a cubic function in standard form, okay? We have ax cubed plus bx squared plus cx plus d. If we were to write the exact same equation in factored form, we would now be able to see the roots, or the x-intercepts, as part of the process. Right? You would just set each of those individually equal to 0 and solve for x. Factored form allows us to see the multiplicity of the roots. And what I mean by that is I can actually write this function, this x plus 2 times x minus 3 squared. I can rewrite it as f of x equals x plus 2 times x minus 3 times x minus 3. Right? This squared really means that we are repeating that factor twice. And that's where multiplicity kicks in. Right? Whenever you have an even exponent on a root, it means that you're multiplying it by itself twice. It's occurring 2 times in that function. And therefore, it's going to behave a certain way on the graph. Okay? Whenever we have odd multiplicity, or you can technically put a 1 here right above the x plus 2, we're saying that this one only repeats itself once. And that also behaves differently on a graph array function. So even and odd multiplicity is referring to the exponent on the root. How many times are we multiplying this root by itself? The multiplicity behind it is going to be even or odd. So let's get into the rules of what even or odd multiplicities do in the graph. If you see this example, I want you to notice 2 things. One, here we have 2 roots or 2 x-intercepts. One is going to be at x equals -2, and one is going to be at x equals 3. Okay? Notice how at -2, the graph is going to touch the x-axis, but it's going to bounce. It's going to bounce back up. It's not going to cross the x-axis. And when that happens, when it touches the x-axis but doesn't cross it, we say that that is considered even multiplicity. And if we recall from our previous slide, even multiplicity means we're going to have an exponent of 2 on that root. Over here, notice how it crosses the actual x-axis. It goes through the x-axis. They're both x-intercepts, but one of them bounces back up, and the other one crosses the x-axis. When it crosses the x-axis, we say that it has odd multiplicity. Now, if we have the x-intercepts, how do we find the roots? Well, basically, we're looking at going backwards. We're looking at moving the -2 to the left side of the equation with the x, and the +3 to the left side. So if we were to move the -2 over to the left with the x, we would have to do the opposite. We would have to do +2 on both sides, giving us x plus 2 as the factor. And over here, the 3, if we subtract 3 on both sides, it would give us x minus 3 as a factor. So here I have 2 factors. The general form of a factor of a function looks like this. We have our leading coefficient times our 2 factors. We'll talk about the leading coefficient in a little bit. Now, if we look at this, we have an even multiplicity at x plus 2, which means we need to have an even exponent right above here. So we put a 2 above it. And over here, because we have odd multiplicity, we can technically put a 1 as an exponent because we only repeat that root 1 time. So if we recall from our previous slide when I was explaining multiplicity and what it is, this is in essence what we're talking about. This function has an x plus 2 repeated twice. X plus 2 times x plus 2. That's why when it gets to the x-axis, it touches it, but it bounces back up, looking like a parabola, x squared. And then when it gets to the other root, because there's only one of them, because we have odd multiplicity, right, it's going to go right through the x-axis. So knowing the multiplicity, or knowing what the picture looks like, allows you to go back and forth from the equation to the graph and the graph to the equation. Now let's get to the leading coefficient. there's a previous video, right, at the very beginning of our previous unit talking about the leading coefficient and the degree of the exponent, or the degree of the polynomial. The leading coefficient is referring to the direction of this graph. What is the graph doing in the long run? As x progresses, the graph is going to go down towards the negative. So technically this cubic function is a negative cubic function. So I know that I'm dealing with a negative leading coefficient. This is a negative x cubed. How do I know that it's an x cubed function? Well, think about it. Here I have x squared and an x. When you multiply x squared times x, it gives us with x cubed. So here we're actually dealing with some sort of negative x cubed function. That has more terms, of course. But in factor form, we write it like this. Let's do a couple more examples. Here I have 3 roots, or 3 x-intercepts. So I'm going to label them as x equals negative 2, x equals 2, and x equals 5. Starting here, I could even go backwards already and write it in factored form, where I flip the signs and I move it over. This turns into x plus 2 in factored form. This turns into x minus 2 in factored form. And this one turns into x minus 5. We're going to be using the factors here in a little bit. So let's go ahead and write our equation. F of x equals a, x plus 2, our first factor, x minus 2, our second factor, and x minus 5, our last factor. If I were to multiply these, I have x times x times x. I have 3 x's, right? This is x cubed. And I know for a fact that this function is not an x cubed function. Okay, so let's talk about the multiplicity. If I look at the first one, as it touches here at x plus 2, it bounces back up. We have an even multiplicity. As I go towards the other one, it crosses that x-axis. That means that that point has an odd multiplicity. And then the final one, it crosses the x-axis as well, so I know we're dealing with odd multiplicity as well. So when I go to those examples, right, this x plus 2 needs to have an even exponent. And the rest will have an odd exponent, 1 and a 1. So again, we don't have to put a 1 because it doesn't change anything. X minus 2 doesn't change anything when it's not being repeated. So you can remove those. Now let's look at the a value. Because if I multiply this here, technically I have an x squared times x times x. This is going to be some sort of x to the 4th function. If you remember or look back to our other videos, x to the 4th is an even exponent. So the arrows are pointing in the same direction. Notice how the 2 arrows are pointing up. Since this function generally, what it means is it's pointing up, this a value is going to be some sort of positive number. Okay, so you can identify whether or not the equation will be negative, whether or not it will be positive after you identified the multiplicity of your function. All right, let's move on. Now let's talk about how do you find that actual a. So far we've been saying whether a is going to be positive or whether a is going to be negative. But how do you actually find the a? Well, here we have a function. We have the factors. Let's write it in factored form. Let's say here we have f of x equals a times x plus 3, x plus 1, and x minus 2. In terms of multiplicity, here we're dealing with odd, here we're dealing with even, and here we're dealing with odd. So the only one that has an actual exponent is going to be at x plus 1. X plus 1 squared, because it's bouncing back at this location. And the other one, it's crossing the x-axis. Okay? Now, how do I find this a value? Well, let's say that you're given an actual point on the graph. Let's say that you actually know this point, or any point on the graph. And let's say that we have 1 comma, let's say 1 comma 3, for example. If I know a point that touches or is going through on this graph, I can label this as my x and my y. And I can plug that point into the equation for x's and for the y's and actually get a solution. So anywhere I see an x, I'm going to plug in that 1. And wherever I see the y, I'm going to plug in the 3. This is what that means. I have 3 equals a times 1. Let's see if I can go back. One plus 3 times 1 plus 1 times 1 minus 2. Notice how I'm substituting the 1 for every x and the 3 for the y. And now since I only have one variable missing, the variable a, I can simplify all of this and solve for a. So let's do PEMDAS. Let's do what's inside the parentheses. Here I have I'll continue this in blue. No, I'll continue this in black. Here I have a 3. Inside the parentheses, I have 1 plus 3, which gives me 4. Inside the other parentheses, I have 1 plus 1, which is 2. And then the last one I have 1 minus 2, which is negative 1. Okay? If I multiply the exponent part, I have 3 equals a times 4 times 4 times negative 1. 2 squared is 4. If I multiply everything on the right-hand side, right, we just did parentheses, we just did exponents, now the next thing is multiplication. 4 times 4 is 8. 8 times 1 is negative 8. So I have 3 equals negative 8a. To solve for a, I divide both sides by negative 8. And a equals negative 3/8. Let's see, let me write this on the side. A equals negative 3/8. If you think about it, look at this function. Where is this function pointing? The endpoints, the arrows are both pointing down. So I was expecting this leading coefficient to be negative, and we did. We got a negative 3/8. So how would I write my function? I would go back to the original one, and I would replace the a with the negative. So I have f of x equals negative 3/8 x plus 3 times x plus 1 squared times x minus 2. And that's how you find the exact function, negative 3/8 part. Now, most multiple choice questions won't require you to find the exact one. You can simply just know that it's negative or it's positive to find your solution. But if you're stuck to a point where you're like, well, I need to know the exact a value, this is how you do it. You plug in the point x and y for the equation, and you solve for a. And then you can get the solution you were looking for. You can just plug it in right where you need it. Right? That's the only piece that you were missing. I hope this has helped. I want to share with you a little bit problem that you can do for extra credit. So if we understand the context of multiplicity and how to find the point, right, then what I want you to do is I want you to be able to use this picture, right, to find the exact equation that it goes through. Find the a value as well. Let's say that this value here is 2, negative 3. So given this picture, given the x-intercepts, given the multiplicity, build me an equation, the exact equation in factor form for this graph. If you can share with me the notes of the work that you did and your solution, send it to me through email. I can replace this 10 points on the next test or on a previous test if it didn't go so well, or I can even replace the 2 daily assignments with a 100. They could be 2 zeros, they could be 2 50s, 2 whatever. The lowest 2 grades that you have as daily assignments, I can replace them with 100s, or I can give you 10 points on a test. All right, guys, I hope this has been useful and helpful. Well, calculator.